Hello, everyone, and welcome back to our discussion about angle of elevation and depression. Forgive me if I haven't posting a lot of videos for a while because I have other priorities to do. But without further ado, let's now begin. So last time we discussed about angle of elevation and its examples. No, actually, I was wrong. We discussed angle of elevation depression and what's the difference between the two. Then we start with having examples of angle of elevation. Now we're going to proceed here, angle of depression. So let's take a look. The person sees a balloon that its distance between them is 3 meters long. What is the angle of declination to the balloon if the horizontal distance between them is 2.72 meters? So suppose wait for a while. Let me just get my pen. So suppose we have this person and then there is a balloon, right? Just imagine. So the distance between the person and balloon is actually 3 meters. It's 3 meters. Now the thing is, what will be our angle of declination to the balloon if the horizontal distance between them is 2.72 meters? So we actually have a given of horizontal distance, okay, which is 2.72 meters. Now, the thing is angle of declination. Recall that in angle of declination is just the same as angle of depression. And remember that angle of depression is just basically an angle below the horizontal view of sight. So if this is your view of sight, then here, the angle here would be your angle of declination. So the question is, where though? You know, where though? Where should we draw this angle of declination? We're going to draw here. We are going to draw here, right here. So here, just imagine there is a horizontal line, and then the angle here is our angle of declination. We are going to find that, okay? So that's basically how you would find angle of declination, okay? So you're going to go here. All right. So it's it's like this basically because if for example this is an object and this another object and then you have a distance between the two of them, if you're going to look for its angle of elevation, so obviously if this is the horizontal line, you will have an angle here because remember angle of elevation is above the horizontal line. Okay? Now, how about for angle of declination? So if it's angle of declination, you're going to draw an angle here. Okay? Then imagine there is a horizontal line here. All right? And that is how you do it. Okay? And here's the question. Now that, for example, if we have a two object here, and then if we're looking for the angle of elevation, we in which we have this one, and if we look for its angle of depression, in which it is this one, located on the top. Does that mean they are congruent to each other? Do they have the same angle? So we will talk about that in the next video, okay? But basically, that is how you find your angle of depression. It's actually like this, okay? So now that we are going to, what do you call this one? Now that we're going to solve this problem, we're going to get this segment, this right triangle here, okay? So here, right, we have an imaginary horizontal line. Not imaginary horizontal line, if you want to know the distance, it's 2.72 meters as well. Okay? Recall that, for example, if you have this one, this line, and then you have a horizontal line, and you wish to have a horizontal line here, which is the same length as this one, so like this, and you want to know the measurement, well, if it's in the same length, okay, like for example, this is 1 meters, then above, if you're going to draw an imaginary line that is the same length and parallel to each other, parallel to this line, then it's also 1 meters. So here we will have 2.72 meters. Okay. So with that, we can draw a right triangle here. So we will have this one as a result. All right. And there we go. And that's it. Okay. Let this one, this vertical line would be their vertical distance. Okay. So with that, we can have a right angle here. This is 2.72 meters. This is 3, and this is the angle. Now, how would you find this angle? So in here, imagine you flip it. You flip it vertically. Once you flip it vertically, it would look like this. An angle, then a hypotenuse, then we have a base of 2.72. All right, just imagine that. Now, how will you find the angle? The first thing I always tell you is you need to know the parts of the legs or the parts of the triangle. So 3 here is the length of your longest side of the right triangle, which is your hypotenuse. So this is your hypotenuse. Now, if you're going to refer to the legs, you need to know what angle you're referring to. So in this case, we are referring to this angle. So in that case, our adjacent is here and our opposite is here. I already explained how would you know if the leg is an opposite and the other is the adjacent. If not, please try to watch the six trigonometric ratios video so that at least you'll have the idea on what you're going to do on labeling a leg if it's a opposite or not. All right. So now that we have 3 as your hypotenuse and 2.72 as your adjacent, we're going to use at least one trigonometric ratio that has hypotenuse and adjacent. So those are either we use cosine theta is equal to adjacent all over hypotenuse, or its reciprocal secant theta is equal to hypotenuse all over A. All right? Either of the two. All right? But what I recommend to you, again, much better if you're going to use the basic one. Unless, what it goes to, unless it is part of the objective that you're going to use this reciprocal function, which is secant theta. So let's go back to the point. So we have cosine theta is equal to adjacent all over hypotenuse. So here, we're going to use this one first. Cosine theta is equal to adjacent, which is your 2.72 meters, all over your hypotenuse is 3 meters. So let's find the angle. So put the word cos here, you will have theta is equal to arc cosine of 2.72 meters all over 3 meters. With that, we can find the angle with our calculator. So 2.72 all over 3 will give you at two decimal places, this is 24.95 degrees. So this is almost as 25 degrees basically. But yes, the angle of declination is 24.95 degrees. That's your answer. That is the angle of depression here. If you wish to use secant theta, is equal to hypotenuse all over adjacent, there's no problem with me actually. However, the problem is commonly for the scientific calculators, I already explained this, there is no secant theta, cosecant theta, and cotangent theta. So you will use its alternative. So let me just erase this handwriting. Just pass backward if you want to know the solutions. So if you wish to know the the alternative for the inverse secant, remember that this is if you're going to get the inverse inverse of secant, this is theta is equal to inverse or arc secant of a hypotenuse all over adjacent. So instead of using this one, you can use this instead. Arc cosine of 1 all over hypotenuse all over adjacent. This is much better. Okay? If you want to have an alternative, okay, just use this. right? If you don't have arcsecond in your scientific calculator, use this one as an alternative. All right. So let's proceed to the next example. A hiker is at the cliff and sees another cliff that is 2 meters below the hikers. If the distance between the cliffs is 2 square root of 2 meters, then what will be the angle of depression to the top, to the tip of the hiker's cliff? By the way, let me be specific here. The distance between the tip, the tip of the cliffs, right? Tip of the cliffs, all right? Basically, their edges, right? Their edges, basically. I forgot to what do you call this one? I forgot to. Oh wait, no. Wait. Yeah. Correct. This is tip of the cliffs, okay? Tip of the cliffs, all right? Correction, tip of the cliffs, right? So now let's draw. So just all right. Anyways, sorry. Someone just messaged me in the messenger. But anyways, right? So this is the hiker, and according him, there is another cliff. So let's assume that this is the cliff. All right. So here, that cliff is 2 meters below the hikers. So meaning, if the cliff that where his hiker is located, which is here, then their distance between them vertically is 2 meters. Okay, from the tip of the from the tip of the cliff up to the tip of the hiker's cliff, but vertically speaking, it's 2 meters. Okay, because it's 2 meters below the hikers. So meaning, vertically speaking, its distance between the tip of its cliff and the hikers is 2 meters. Now here, the distance between the cliffs, I mean the tip of the cliffs, meaning from here up to here, is 2 square root of 2 meters, then what will be the angle of depression of the tip of the hiker's cliff? So again, where would you draw a angle of depression? It's always basically, when you're going to draw, it's always basically below the horizontal line. But there's no horizontal line here, just like what goes one? Just like in the first example. Then you will draw an imaginary horizontal line here. Okay? Draw an imaginary horizontal line here. Then you will form an angle of depression here. Usually, angle of depression is on the top. Okay? So draw a horizontal line here. Okay? So with that, we can get this segment to find that angle, or to be particular, angle of depression. So we have this one. So this is 2 square root of 2 meters. This is 2. And do not forget to include the right angle because it's a right triangle. And that's it. We're going to find that angle. So if you're having a hard time, try to flip it vertically. So by doing so, you will have this as a result. So theta, then right angle 2, then 2 square root of 2. Now, if you're going to notice, oh wait, no, I was wrong. 2 square root of 2 is on the hypotenuse, or the longest side of the right triangle. Okay, so what's next? Now, if we are basing our scenario with this one, then we're going to find the angle based from the given. So we have a given of hypotenuse and a leg. This is hypotenuse and this is a leg. So what leg is this though? Is it an adjacent or opposite? Since we have the angle here, then this side is your opposite. So we're going to find a trigonometric ratio, or at least one trigonometric ratios that has a hypotenuse and opposite. So there are two, which is sine theta is equal to opposite all over hypotenuse, and its reciprocal, cosecant theta is equal to hypotenuse all over opposite. So let's start first with the basic one, which is the sine theta, this one. Okay, we're going to use that. Let me just erase the drawing here since we already have a right triangle. Okay, so we have sine theta is equal to opposite all over hypotenuse. Now let's substitute. So your opposite is 2 and your hypotenuse is 2 square root of 2. 2 and 2 square root of 2 are both divisible by 2. So 2 divided by 2 above, 2 divided by 2 above is 1. And 2 square root of 2 divided by 2 is square root of 2. So we have sine theta is equal to uh, 1 all over square root of 2. Now we're going to find the angle. So put sine here. So what happens is we will have theta is equal to arc sine of 1 all over square root of 2. So if we're going to use our calculator, I do believe this is 45 degrees, but let's take a look. So arc sine of 1 all over square root of 2, wait, this will give you, yes, I'm correct, exactly 45 degrees. So the angle of depression is exactly 45 degrees. And that is how you find your answer. And similarly, on how we discussed on the first problem, if you wish to use its reciprocal, which is cosecant theta, it's okay. All right. If you have, again, a calculator that has cosecant, so be it. However, if you don't have, use its alternative. All right. So let me erase this one, so that you could know the alternative. Okay? So if you're going to get the inverse of cosecant, you will have arc cosecant of hypotenuse all over O. So if you wish to use its alternative, you're going to use arc sine of 1 all over hypotenuse all over O. Okay? Instead of using this one, just use this one. Okay? So next problem. A person looks down at an object at an angle of 20 degrees. The length of the distance between, actually, yeah, the person is you, by the way. Okay, the person is you. So let me just fix this one. Forgive me if I have a lot of mistakes in terms of writing a problem. Okay, so let me fix that. uh, Wait, let me fix that. All right, so let's change the subject. You look down at an object at an angle of 20 degrees, and the length of the distance between you, which is correct, you and the object is 50 centimeters. What will be the horizontal distance between you and the object? So this is you, all right? And you look down at an object at an angle of 20 degrees. So suppose this is the object, all right? This is the object, suppose. You look down. It's like you're tilting your eyes or your head just to see the object below you. So you see it. So if this is your uh what do you call this one? If this is your initial view, because before you go down, obviously you're going to look straight, right? Because that's your initial view or initial view of sight, basically. Then after that, you look down just to see the object. So when you move down, you form an angle of 20 degrees here. All right, this is 20 degrees. And the length of the distance between you and that object is 50 centimeters. To be particular, what uh, what I am actually referring here, distance between you and the object, it's how should I say this? It's basically uh your eyes. Okay. So I was wrong. Forgive me. Between your eyes and the object. Okay. There we go. Your eyes and the object. Because we are looking at the view. I view. Right? Once again, forgive me for my mistakes. It's actually your eyes. Okay, because you're starting at here. Because if you're referring to the length of the distance between you and the object is 50 centimeters, then we're actually referring to its horizontal distance. You get me? So if that's the case, that's the answer. But the way how I imply it, it's not horizontally speaking, you know, but rather starting from your vision, so from your eyes. Okay, so forgive me, right? So this is 50 centimeters. Now, what will be the horizontal distance between you and the object? So in here, we're going to take a look at the scenario here. We can get its segment. We have the imaginary horizontal line, which is your point of view, all right? Like initial point of view. Then you move down, which is here, this one. That is your hypotenuse. So we can get this one. This is 20 degrees. And here, this is 50 centimeters. And here, you can imagine there is a vertical side. Okay. And because of that, we can have a right angle here. Right? We have a horizontal line, we have a vertical line. So both of them are perpendicular, so they have a right angle automatically. All right? So we can do that, right? We can do that. So now the question is horizontal distance. How will you get it? So flip it vertically if you're having a hard time. So you have this. So 20 degrees, then 50 centimeters, then right angle. So 40, oh wait, no, no, no. This is 50 centimeters, not horizontal, because that's what we're looking for. Now, how would you do that? So remember that we had a video discussion about it. Like if you have a hypotenuse in a certain right triangle, okay, you have a hypotenuse, you have an angle, right? So how will you find the sides of the right triangle? Or to be particular, the legs of the right triangle. So just like here, we have a hypotenuse of 50 centimeters and we have a given angle. So how will you find the horizontal side and the vertical side? Recall that if you're looking for the horizontal side, or basically, yeah, the base basically, you will use this. X is equal to the hypotenuse times cosine theta. All right? While on the other hand, if you're looking for the length of the vertical side, it should be hypotenuse times sine theta. Since we are looking for the horizontal distance, we are going to use this. Okay? So x is equal to your hypotenuse, 50 centimeters, times cosine theta. So cosine of 20 degrees. So what would be our answer? So let me use our calculator. 50 cosine of 20. So approximately at two decimal places, we have 46.98 degrees. 4 degrees to, sorry, centimeters. 46.98 centimeters. That is your horizontal, what? Horizontal side. Okay? Or horizontal distance, basically. 46.98 centimeters. Okay? 46.98 centimeters. You can round it off into one whole number because if you're going to round off into a whole number, you will have 47 centimeters. All right? So, yeah, it's up to you. So, there's another part of this one that we're going to discuss about angle of elevation and depression. Right? So, stay tuned. And that is all, guys. See you soon.